Okay, so here's what you're going to do. You're trying to find if there's a significant difference in reaction time when you're texting and driving or when you're just driving straight up. And you're going to use it through a simulator. Okay, and the simulator is this reaction time test right here where you are going to be driving down the highway, and then as soon as the little red sign comes up, you're going to click on it, and then that'll give you a time for your reaction time. So I'm watching. Oh, yeah. All right, so that was 742. You just do this a couple times just to get your bearings on this activity. My computer looks like it's going pretty slow. That might affect this a little bit. But you're going to do it 10 times and record it. So 582. So I make a spreadsheet. And you got to make a spreadsheet. Please also write it down on paper. But 582, this is control, trial number 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So there's my control, first one, milliseconds. I'm not going to put the milliseconds in the box. I'm going to put it up here because if I put an M and an S in there, it's not going to work. Okay, you got to not have that. So then I do another trial. Oh, diggity. Okay, 555. You're going to do this 10 times to get 10 data points. I'm not going to do it all 10 times right now. I'm just going to do 3 to show you. But you're going to do it 10. Your sample size is going to be 10. My sample size is going to be 3. So that's 702. Okay. So down here, I'm going to find the average. I'm also going to find the standard deviation. Okay. And I'm going to do that with equals average. Boom. I highlight all those. Equals STDEV. Get those. Now, there I go. So there's my average and there's my standard deviation. I'm going to shorten that there. Then I'm going to do with phone. So this is my independent variable. I go back over here, press try again, start surfing the web. Okay, surfing the web, checking my emails, and I'm going to click on that when, oh, got it. Okay, 917, so 971 with the phone. Got it. Again. Come on. Got it. 731. Okay, 731. All right, one more time with my phone. Oh, got it. 1379. Okay. So, yeah, for those 3, you're going to do this 10 times. You're going to find your average. Highlight them. You have to make your own little spreadsheet. Standard deviation. Highlight your numbers. Okay, so I have my average and my standard deviation for both trials. Got it there. I'll make a little table there. Just makes me feel better about it. Then I go back here and all this stuff should be put in there. All right. What allows you to mathematically compare these two sets of numbers. That's the average. Use your answer number 2. The control was that. The control average is whatever it is. The well-being on the phone is what's the average there. So based on just looking at the averages, what do you think the reaction time is fastest? Look at that. So then read through this about standard deviation, standard error. Standard error is another way to measure variation. So we've done standard deviation, which is S. Now here's the formulas for it. You don't need to use those formulas. You already did it on the spreadsheet. Okay. So you then go and you graph this. So you need to make 2 graphs. One is plus or minus a standard deviation. One is plus or minus a standard error. So let's talk about standard deviation, standard error. So here, the average will be what the bar goes up to, 613. And you go up a standard deviation and down a standard deviation. So average plus STDEV, average minus STDEV. So you can do that here, average. Your number is going to be different than mine because you should have 10 trials. Got it. And then this minus STDV. So that's my range from 534 to 691. There you go. Equals this plus this. So that goes up to like 1300 something. Equals this minus this. Is there overlap? Ooh, it's super close. Oh, there is not overlap because the 691 does not go up to 699. So there's a significant difference here just based on these three trials. But you'd graph that out now. You'd graph that here on the standard deviation. Now, standard error. Standard error, you just take the standard deviation and you divide it by the square root of the number of numbers, the sample size. So you're going to take your standard deviation, you're going to divide it by the square root of 10. Okay, because that's how many trials you got. So standard error, a new form of variation, and it is going to be equal to the standard deviation divided by SQRT of 10. Because actually, for me, though, it's 3 because I only have a sample size of 3 here. But for you, it will be 10. So there, I have that. My standard error is 45. And over here, for this standard error equals the standard deviation divided by the square root of 3. And I actually just did that for me. SQRT divided by 3. Got it? Do that. So you're going to have to graph that where you graph again. So you go average plus this standard error. Average minus the standard error. You're going to put that on a graph. Okay. So equals the average plus that number equals the average minus this number. Got that. Let me see if I can just drag this over. Can I do that? I think I just did it. There we go. Okay. So now you're going to have a bar that goes up to 613 both times and 1027, and then you do the little tally thing all the way up to 1216 and all the way down to 837. So now there's definitely a significant difference when you're talking about within one standard error. So the standard error tightens up your tallies out further. So is there a significant difference to one standard deviation? Yes or no? Is there a significant difference to one standard error? So the first one is looking at this graph. Number 8 is looking at this graph. Number 9 is looking at this graph. Okay. Now to number 10. Compare using plus or minus 2 standard errors. So you go back here and you go plus or minus 2 standard errors. So here you go average plus 2 standard errors and average minus 2 standard errors. And this time the tallies are going to get a little bit further out, or like the little tails are going to get further out. So you go here and I go equals average plus 2 times the standard error equals average, equals the average minus 2 times the standard error. Okay. And same thing over here. See if I can just get away with dragging that over, see if that works. 2 times. I think it did. Oof, it did. Now, when I look at this, I see that this one goes down to 648 and this one goes up to 703. So when we look at 2 standard errors, are we within 2 standard errors? There's overlap then. Compare using plus or minus 2 standard errors, and that's the standard deviation divided by the square root of the number of numbers, divided by the square root of 10 for you all. So is there a significant difference to 2 standard errors in reaction time? No, there's not, because there's that overlap. At least for me, there wasn't. So what you're going to do now is you are going to take and make another spreadsheet where you have these 2 sets of numbers, and you're going to do it with 1 standard deviation and 2 standard deviations. So you got Bill, Ted, and Bruce. You got to make a Bill, Ted, and Bruce spreadsheet. Bill, Ted, and Bruce spreadsheet. And I'll just kind of copy this over, use it here. Basically, just give me practice on spreadsheets today. So, Bill, 91, 93, 95, 89. Ted, 89, 85, 74, 99. Bruce, 68, 70, 70, and 69. Okay, so you find the average for all those people. Got it. Highlight those. There's the average, 92, 86, 68. Okay. Then we find standard deviation. That's equals STDV. I'll do highlight those 4 for each person. Ooh, that's a pretty tight standard deviation. Okay, so I found the standard deviation for each. So now I'm going to do like plus a standard deviation minus standard deviation. And then I can do plus 2 standard deviations and minus 2 standard deviations. And for 14, it's just asking you to look at number 12, plus or minus 1 standard deviation. But for 13, you're plus or minus 2 standard deviations, so your spread should be even bigger. Then you answer 14 and 15. Okay? So for this, I'll kind of go over real quick. Average plus an STDEV, average minus an STDEV. Get plus this and equals this minus this. When you have your spreadsheet set up really nicely, you can do this beautiful thing like dragging across. And these Bill and Ted overlap, but then Bruce is significantly lower, just 1 standard deviation. So you would do a bar graph that's 92, 86, 68. And then you do it again with average plus 2 STDEVs and average minus 2 STDEVs. And you go like this. You have boom equals average plus 2 times the STDEV and equals the average minus 2 times the standard deviation. Good, and that kind of shows a little bit more of a spread by doing 2 standard deviations. And these 2 still overlap. And this one, ooh, okay, it looks kind of like Ted and Bruce overlap now. Ted and Bruce overlap because Ted had that 74, which makes them overlap down a little bit further when you do 2 standard deviations. But the question is only asking you about within 1 standard deviation. So down here, then you're looking at artificial intelligence used for having computers to drive cars. So we looked at reaction time and how much it slows down your reaction time to be on cell phones. Make a jump. Now, could we just be on our phones the whole time and have self-driving vehicles drive us around? That'd be pretty sweet. All right, that video should help you for doing that assignment.